Hello, let's do the New York Times Hard Sudoku for March 31st, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I'm suspicious of this 251 here. In fact, a lot of this on the top I'm suspicious of, but okay, I do have this one and this one looking in. So there's a 1 in one of these two cells, not both. One of these two cells, we use corner marks to designate that. And so now what these ones do is they do something called pointing. What we have said here is that in box 2, the 1 can't be in any of these cells, right? So the 1 ends up in one of these two cells only. Now those two cells, coincidentally, are both in row 1. And so no matter where the 1 ends up, it's going to be row 1's 1. Row 1 has exactly 1, 1. I know it's a lot of ones. There's a single 1 in row 1. In this row, there is a single 1. There we go. And it's here. It's here or here only, which means it can't be over here. So they do what's called pointing. They point at the rest of the row and say, you're not 1, because I need to be the 1. And so this one also looks in here. This isn't a 1. So 1 ends up in one of these two cells now. The important thing is these are no longer able to be 1. We also have the same thing with 9s. So these 9s look into here. These aren't 9. So 9's in one of these two. So 9's going to point left, 9's going to look left, and 9's going to be in one of these three cells. But we've also done something else here. What we've done is we've proven that this is a 1-9 hidden pair. If you think about it, what these corner marks are telling us is that within this box, the 1 is limited to these two cells, and the 9 is limited to the same two cells. Only those two cells for both of them, and they're the exact same two cells for both of them. So one of these cells will end up 1, and one of these cells will end up 9. We don't know which is which, but we know that they're going to end up 1, 9 in some order. So how could they be anything else, right? How could this be a 5? If we try to make this a 5, well, this cell needs to be both the 1 and the 9. It's the only cell left that can be 1, and it's the only cell left that can be 9. That's not going to work. We're going to end up excluding the 1 or 9 from the box. So we can actually convert these to what we use center marks for, which is that these cells can only be those two digits. And we end up with a 1-9 pair here. Now this 8 looks in, and these can't be 8 anymore because of the hidden 1-9 pair. We moved 8 from those cells. So 8's in one of these two. Actually, we have two 8's looking up now. This can't be 8 anymore. So now 8 is placed. Even better. Now we're left with a triple here, and let's just think about what that triple is. It's not the 1, because the 1 and the 9 are up here. It's not 2, 3, 4. It could be 5, it could be 6, could be 7, can't be 8 or the 9. This cleans up a little bit. We know the 5 ends up in one of these two cells because this 5 was looking in like this, and these aren't 5 anymore. So that's going to point down, preventing any of these from being 5. I'm not sure we can do anything with that yet, so we'll just have to try to remember that the 5s point down. Unless there's a cell that looks specific. This cell looks especially limited to me. In fact, why don't we just think about what digits remain besides the 5? So we need the 2, 4, 6, 7. That's it. 2, 4, 6, 7. So this is only 2, 4, 7 because it's not 6. Neither of these can be 4 actually. So 4 in this column actually just only goes here. Now that I see it, these two 4s looked into the box as well. Could have seen that. And so now let's just fill these with their candidates. It's 2, 6, 7. And that one's not 7. Okay. And we know the 2 is down here. Yeah, and 2 in this box is over here because this 2 looks down. In fact, this box is down to 4 different digits. So this row's down to 3. I'm gonna look at any rows, columns, boxes that we've touched that are down to 3 or 4 or fewer digits. So these can be 2, 5, 6, 7. I'm gonna fill that 2, 5, 6, 7 because these can't be 2. This can't be a 6. Ooh, these can be any of those. So I'm actually not going to keep these marked. I don't like having 4 digits marked in a cell. That does make a 5, 6, 7 triple here. This is what's called a naked triple. So let me explain what naked versus hidden means. Naked is using center marks. It's using what we've already put on the grid as center marks. Hidden is using a more... Hidden is asking the question, where can these digits go? Whereas naked is asking, where must these digits go? I don't know if that's a good way to distinguish it. But this is a naked triple because what I'm using is I'm using the center marks that I've already externally put into those cells, right? This can only be 6 or 7 because it literally can't be anything else. This can only be 5, 6, or 7 because it can't be anything else. This can only be 5, 7 because it can't be anything else. Taking these 3 cells together that share a column, because they share a column, there's going to be 3 different digits that go in the green cells. That's true. If I were to highlight any 3 cells in any row, column, or box that share a row, column, box, these 3 are going to have 3 different digits. These 3 are going to have 3 different digits. These 3 are going to have 3 different digits. It's part of Sudoku rules, right? So that's true of these as well. The green cells are going to have 3 different digits in them. What 3 different digits are going in there? Well, if I just completely enumerate every single digit that's present as center marks, I only get 5, 6, 7. That's it. These 2 can be 5, these 2 can be 6, all 3 of them can be 7. But what matters is 5, 6, and 7 are the only digits I can even account for in the center marks. That's only 3 digits. And we need 3 digits. So those are the 3 digits that are going into green. In some order, they will end up 5, 6, 7. Maybe they'll end up 5, 6, 7 like this, 5, 6, 7. Or maybe they'll end up 5, 6, 7 like this, 5, 6, 7. Or maybe they'll end up 5, 6, 7 like this. There's a lot of different ways they could become 5, 6, 7, but they will become 5, 6, 7. And because these 3 cells will be 5, 6, 7, these cells cannot be 5, 6, 7 because the column only has 1 of each. And we know they're going to end up in green. So these cells are not 5, 6, 7, which means they're whatever's left over, which is the 1, the 3, and the 9. This one can't be 9. So for every naked technique, there's an equivalent hidden technique. In this case, there were 6 open cells left in this column, and 3 of them were used in a naked triple. So the remaining, the 6 minus 3, which is still 3, coincidentally, the 3 remaining digits make a hidden triple. If we had found, say, a naked pair instead of a naked triple, then we would have a hidden quadruple, right? They add to the number of open cells in the row, column, or box that you're using. So these purple cells are also a hidden 1, 3, 9 triple. And if you look at where 1, 3, 9 can go in this column, they cannot go in the green cells. So they must go in the purple cells. That's a hidden triple. Because none of the green cells can be 1, 3, or 9 because of the blue cells that I've highlighted here are taking 1, 3, and 9 completely out of the green cells. And then our givens also aren't 1, 3, or 9, right? Because our givens are some other digit. And so we need 3 cells in the column to put 1, 3, 9 in. So we're asking the question, where can 1, 3, 9 go? And the answer is they can only go in 3 cells. And they need 3 cells, therefore those are the 3 cells they go in. So we wouldn't be able to put a 5, 6, or 7 into any of those cells because they have to be 1, 3, 9. So the deduction is identical. It's just 2 different ways of looking at the same deduction. So hopefully, I'm spending a lot of time on this because I always get questions about it. And I feel like it's really important to understand fundamentally and really, really understand the basic idea and logic behind why those work, rather than me just saying, look in the same row, column, or box for 3 cells that are the same 3 digits, and then eliminate that from the rest of the column. If I just try to make you memorize that pattern, you're going to apply it wrong, or you're going to say to things to me like, how is this a 5, 6, 7 triple? This one's only 6, 7. This one's only 5, 7. I get that question a lot because you're taught to look for specifically 5, 6, 3 cells that have the same 3 digits, without realizing that removing one of the digits does not change the logic, right? But if you understand how the logic works, then it's pretty clear and almost trivial to understand, yeah, of course I can eliminate digits from my triple and it still works like a triple. Okay, so I just completely derailed my whole solve with that explanation, but I hope it was useful. So we end up with this 1, 3, 9 triple here. Now, if you look at this column, or if you just look at the 1, 3, 9 triple, you'll see that 3 ends up in one of these 2 cells. We can corner mark that. You can also just see these 3s looking down. This 3 looks in. But, okay. We also end up with a 5 in one of these 2 cells. So these 2 cannot be 5 anymore. So let's actually pencil them because it's down to 3 digits. It's 2, 6, 7. They can't be 5, or we would not be able to put 5 in this column anywhere. All right, I'm going to look at this row now. This row is down to 2, 6, 7. And you can see that this cell can't be the 2 or the 7. So it can only be 6, and that resolves the whole row. That also resolves this. It resolves The entire triple that we just found gives us this 2, 7 pair. Gives us this 2 and 7. Okay. Because this is a 2, 7 pair, again, this is a naked 2, 7 pair. I think for some reason, I don't know if it's for some reason, but I feel like people intuitively understand pairs better than triples. Because they always, you can see that these two cells are just identical to each other, right? And because they have to be different from each other, one will be 2, one will be 7. For whatever reason, it takes a bit of a leap in logic to expand how you're thinking about that in the right way, to expand that to triples and quads and things like that. I think it's understandable. 1, 5. What did I say? 1, 5, 6, 9 is what's left. So this is 1, 6 only because it sees 5, 9. I don't really want to mark these. These are all 5, 1, 5, 6, 9. Okay. So let's take a step back. What did we get? We got a lot of digits. So let's follow up on them if we can. I got this 5, for example. Yeah, okay, that looks in. So 5's up here. I got this 1, 9 pair. Maybe we should think about what's left in the row, because they can't be 1, 9 anymore. So they're from 3, 4. Okay, the 4 is interesting because it's not here. So 4 is over here. The 5 is over here. The 6 is already in the row. And then we need 7 and 8. I mean, these two cells both see a 7, if that's at all interesting. Okay, I don't think they're worth marking beyond what I've just done for now. Let's look at this band here. We have 2 3s looking in, so 3's up here somewhere. We have 2 6s here, and this 6 looks down. We can place this 6. Let's follow up on that by having these 6s affect this box here, putting a 6 in one of these two. We also have 6s looking down here, putting a 6 in one of these two. Oops, not 9, just 6. We have this 4 looking down and this 4 looking in. And these two aren't 4. So 4 ends up in one of these two. And that's going to point left along with this 4 looking left. So 4 ends up over here somewhere. The important bit is these aren't 4 anymore. Oh, I have these 2 3s looking up. That's helpful. It places this 3. There's still 2 places for 5, but we do get a deet in the corner. Okay, anything else around here that I can do? I do have 2 9s and this 9. So 9 ends up in one of these 2 cells. Okay, I'm looking at this 1 6, but the 7 is the only thing that might be interesting, but it's not. We do have 2 5s looking in here, and this 5 looks in, so 5's in one of these 2 cells. This cell, I'm starting to notice it's avoiding a lot of our corner marks, right? It's not 3, it's not 4, it's not 5. So what's it down to? Now, the first thing I like to do is I like to get a count of how many digits I'm expecting. It can help prevent human error, right, when you're penciling. So I'm expecting it to not be 1 6, and I'm expecting it to not be 3 4 5. So that's 5 digits, and I'm also expecting it to not be 7, which I didn't account for in any of these corner marks, right? So it should be down to 3 digits. So that's definitely worth marking. So it could be 2. It can't be 3 4 5 6 7. It could be 8 9. So that's exactly the 3 digits we are expecting, or the count at least. Now, here's something I'm noticing, right? 4 open cells in this row. This cell can only be 3 digits. So there's definitely going to be a digit that's limited over here. We just have to find out which one it is. Looks like it's the 7. So where does 7 go in the row? It's not here, right? And it's not here. So 7 ends up in one of these 2 cells. Yeah, and 7 ends up over here somewhere. So it's not super helpful. Let's see. What else can we do here? This cell's avoiding some corner marks, and so is this one. Why don't we think about this whole row for a second? Because this can't be 7 or 9. So this is down to 2 8 only. Because we need 2 7 8 9. This one can't be 2 or 9, so this is only 7 8. I think this can be any of 2 7 8 9, so we're not going to mark it. Okay. I think at this point I'm going to move on to the next band here. We do have 2 8s looking in. That just places an 8. So now this can't be 8. So this is down to 2 7 9, so we can mark it. I had that fresh in my mind. What else do we have going on here? Okay, so I'm seeing this 5 here. Takes 5 out of these 3, and this row still needs a 5. So this is the only place in the row for 5, so it must be. This is from 1369. It can't be the 3, so it's only 169. The 6 ends up over here. Ah, this is something to always look out for, because it can save you huge amounts of time. So what I did is I had just corner marked 6 into 2 columns out of 3 for a box, right? The 6 ended up in these 2. What you want to do is you want to scan left and you want to scan right for other places that you may have limited. In the other 2 boxes, have you limited that same digit to the same 2 columns only? And the answer is yes. I scanned to the right and I saw that 6 was limited to only rows 7 and 8 as well in this box. You can think about this in a few ways. Some people think of it like an X-wing. I don't think it's worth thinking of it like an X-wing. I mean, you can, but that kind of excludes other options, like what if 6 was available in all of these cells? This logic still works. Because what the logic is this box is going to have a 6 in row 7 and 8, and this box is going to have a 6 in row 7 and 8. And the question is, where is poor 9 getting its 6 from? Row 9. Where's row 9 getting its 6 from? And the answer is only right here. These can't be 6. And none of these are 6. So therefore, the 6 has to be here. So what you found is a hidden single, or you found claiming. Either way, it's helpful. So we can place that 6 there. And this is down to a pair for the row, but one of them's a 1, and this 1 tells us that the 1 has to go here. And the remaining digit is a 9. That clears out this 9, but there's still 2 places for 9 in the box, so we can't immediately react. But what we can do is we can scan down and see if we've, have we limited 9 in the other boxes, but then we notice that 9's already placed in one of the boxes, so that's not going to be helpful. But I'm always scanning for that stuff. I'm not always finding something, but I'm always scanning for it. Ideally. 2, 3, 4 is left in this. I'm just going to pencil it. This one can't be the 2. And so again, like I'm seeing 3 and 3 here are limited there, but row 9's already done. So like that's not going to be helpful. But it's just if you habitually scan for it, then you'll be able to catch claiming and hidden singles, where normally it might be a struggle to have seen those. I'm going to think about this column again. Anytime we're down to 4 or fewer, always good to at least think about it. We need 3, 4, 7, 9. This one can't be 4, so this is 3, 7, 9. This one can't be 3 or 9, so this is just 4, 7. I think this can be any of 3, 4, 7, 9, so we won't mark it. Okay, what else can we do here? I was looking at this band. I don't know if I finished. I found quite a bit, that's for sure. Things I'm looking out for is like this kind of geometry where it's these 5 cells left. Anything that would take something out of these 3 is going to be super powerful. But unfortunately, we only have the 7, 8, which are already in the box. In fact, we have all of our 7, 8s for the band done. I don't know that we're going to find anything else here. 7, 5. Oh, the 5 is helpful, though. And not the 8, though, because the 8's already in the box. But 5 is looking in here, right? So that does something similar to what I was saying, where 5 is limited to these 3. This cell's avoiding the 5, 6. So we've got 1, 2, 3, 4, 5, 6. Not the digits, but the count, right? We have 6 digits that this definitely isn't. And I'm also seeing that we're seeing a 4, which isn't even corner marked in this box right now. So this is down to 2 digits. It's going to be the 1 and the 2, actually. It can't be 3, 4, 5. Where's the 6? The 6 is up here. 6, 7, 8, 9. So down to a 1, 2. We've got the 1, 3 here. We've got 2, 3, 4 here. There's nothing really that matches up, unfortunately. Okay. Let's do some vertical scanning. I did do a lot of vertical scanning as we went, but it's always possible I missed something. So always good to just do it with intention before moving on. This stack is obviously done already. It's down to a very few digits. They're all penciled in. How about over here? I got the 9s. I think I found everything. Everything obvious, at least. This box is down to 4 digits, and we know these aren't 1 and these aren't 5, so they're going to be fruitful. So in the box, we need the 1 and the 5, but what else do we need? We need a 7 and 8. So that these aren't 7. So actually the 7 ends up in one of these two cells. I missed that with the scan. And that's actually really important. I'm sorry I missed that. So these 7s point down, making this not a 7. So it must be an 8. And then now in this box, 7 can only go there. And now in the box, 9 can only go there. That's what's great about our corner marks is they can chain react like that. You just get suddenly a ton of digits that otherwise you would have had to rescan for and might have missed. Huge time saver to have these seeded corner marks, and that's why we do it. In this box, we need 1, 4, and 5. The 1 can only go here because of this one here. That's kind of what I was talking about with like geometry. This is down to 4, 5. I don't think it's resolved, but it is a pair, which means this isn't 5. So now this is the only place for 5 in the box. This is down to, this is a 2 and this is a 5 for the column. This is not a 2, so the 2 in this box goes here. I think we've just found enough to collapse the puzzle. This is down to 1, 4, 5, 7. It's not 5 or 7, so it's only 1, 4. In fact, this is just 1, 4, 6. Do anything with that? I'm not seeing anything immediate to do with that, actually. So we'll keep looking. There's not much left to this puzzle. This is 2, 4, 7, not a 2. So what we want to think about is where's 2 in the row? Answer is only here. This is the 7. This is down to 4, 7. That's a pair. So this is going to be a triple. It's going to be 2, 3. The 2 can only go here. The remaining digits are 3 and 8, and the 8 can't go there. So that's 3, that's 8. We get our 4 and a 3 resolved. I think this entire bottom band is going to resolve. Yeah. This top box is resolved. This whole box is going to resolve. This box resolves. This box resolves. And the last box in the puzzle, of course, resolves. 3, 7, 8. The 7 goes here. This is the 3. This is the 8. Nice. 21 minutes. I'm not worried about time. I spent a long time explaining some very important things. So hopefully that was helpful. Do let me know any feedback you have and how you did. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.